So this is just the other notation. F is the outside function. So there's the derivative of the outside function. And then you multiply by the derivative of the inside function. The key to the chain rule is keep it simple. Don't try to do too much at once. You do one little derivative at a time. Just like we saw with these examples. Oh, I see the 5 out in front. All I need to do is put the 5 out and put a 4. I don't worry about changing anything else. Just do that simple rule to begin with. Then I look inside my function. Could I do the derivative of the inside? Yes. That's just 2. So just simple steps at a time. For the most part right now, we're going to deal with something inside of power rules to have a function inside of a function. Okay. So there is a long-winded way of writing these kind of questions. Eventually, I think you'll just be able to do them directly. But I'll show you how you could use the formula. If you memorize the formula using this notation, okay? This is sort of a way to say I have one function inside of another function. What you do to start with is you make the inside some letter. So you choose u, and then u is equal to 3x plus 6. And then your function dy dx is dy du times du dx. That's the formula that we had before. This is your outside, this is your inside. But what it allows you to do is if you make u equal to 3x plus 6, then your function just becomes u to the 5. Okay? Where u is equal to 3x plus 6. So if we look at this formula now, which is the chain rule, it says we can find the derivative dy dx, which is what we want to find, by first finding the derivative of dy du. Okay? What this means, dy du, the letter on the bottom is just what variable are you doing the derivative. If we have y equals u to the 5, we'd be finding dy du. If we had y equals k to the 5, we could find dy dk. So this letter on the bottom just says what variable is in the function that you started with. It can act the same way that x acted before. So if we have y is equal to u to the 5, dy du is just 5u to the 4. Does that make sense? That's a simple power rule. Yes. On the top we have the function. On the bottom it's telling which variable it's a function of. Du dx means you have to have a function u, which we have here, as a function of x, which we have there. So du dx would look at this equation and say, well, the derivative is just 3. So then dy dx would be dy du, which we've already figured out was 5u to the 4, times by du dx, which we figured out was 3. And finally, you just substitute back. Well, since u was equal to 3x plus 6, you'd have 5 times 3x plus 6 to the 4 times 3. In the back of the book, they will take that 5 and that 3 and multiply them together and get 15. Okay, now that we've done the long-winded way, that's the last time I'm going to use that. And now we'll go to how we're going to do the same question thinking of working our way outside, working our way in. So we're going to copy this question. And I would say y prime equals, well, they asked for dy dx, so I'll write it that way. Dy dx equals. I recognize that if I'm looking from the outside in, that I see the power of 5 first. So all I'm going to do is do a simple derivative. The 5 would come out in front. The inside stays the same. Subtract 1 from the exponent. That's doing the outside. Then I look inside. Is the inside something that I could take the derivative of? Yes. What's the derivative of 3x plus 6? It's just 3, and we're done. Okay? For the most part, you wouldn't even have to simplify this on an exam, because they would expect that you know how to multiply 3 times 5 if you've made it to calculus. And this would be fine to leave your answer like that. Yes? Then you would do, yeah, then you could do that. Exactly. And we'll do some of those with functions inside of functions inside of functions. And if you tried to use the formula, it would just look nasty, but if you just work from the outside in, it's not so bad.